5.1 RSG. I am not going to spend a whole lot of time on this video since we went over this section of the RSG in class today. This is really just for those who are absent and maybe you just need a little bit more time to listen to what I talked about in class. So it's not going to be much different than what I did in class. If you're looking for me to be going over these for you, that's not going to happen. I'm not going to work out a single one of these for you in this video. This is more just, let's refresh these, let's review. Let's refresh these, let's review, and maybe talk about some of the formulas. So in the ready, you are looking at perimeter and area and volume. In 1 through 4, you guys are looking at a specific shape, and that specific shape, if I read these, calculate the area of the perimeter of a rectangle, the area of the rectangle, the volume of the rectangle, and then you're looking at the units. Since we're talking about a rectangle here, let's just talk about how we find the perimeter, the area, and the volume. Perimeter, hopefully you guys remember that perimeter is when you add all the sides. So it might help for you guys to draw pictures here. If you need that visual, draw the rectangle, label your sides, find your perimeter. Area of a rectangle is length times width. Again, you can draw a picture. And the volume is length times width times height. So please, take your time, draw pictures. If you need to Google something, Google it, see how the formulas work. But it shouldn't be that bad. Please do not skip 4, explaining how the units change. That's specific to how does it change from perimeter to area to volume. To answer that question, if you're struggling, you might want to look at what are you doing to find perimeter? What are you doing to find volume? What are you doing to find area? And that might help you with your units. They should not be the same units for all 3 of those. So be careful with that. Number 5 is a bonus question if you guys want to work on 5, which is the surface area of the same shape as number 3. You're welcome to work on the surface area, but it's not one that I am like, you have to do this. I really need you guys to just focus on perimeter, area, and volume. Now for 6 through 11, you're looking at another shape now. The shape in 6 is a circle, then it says the circle, the same circle, then it's the volume of the ball, and another ball. So we're looking at circles and spheres. Well, in 8 and 9, they give you the formula. Just be careful with your calculator in 8 and 9. For 6 and 8, calculate the circumference. The circumference of a circle, if you guys need it. If not, go ahead and get to work on this. But if not, it's 2 pi r, or it's pi times the diameter, or diameter times pi. Here you're given the radius, so you really want to it's okay to just use 2 pi r. Now this is saying to go ahead and use 3.14 for pi. You're also welcome to use the pi button. I strongly encourage you guys to use the pi button when you're given the use of a calculator. When you're not given the use of a calculator, then yes, you would use the 3.14. But otherwise, use the pi button. 7 wants the area, so in case you need the area of a circle, it's pi r squared. And be careful using your calculator. Make sure you're plugging things in correctly and that you're following order of operations. 10 and 11, it's asking you again about the units. So please make sure you guys are answering 10 and 11. Do not skip 10 and 11. The set. This is what we discussed in class today about cross sections. So please don't forget, a cross section is when you take a 3-dimensional shape and I slice it. What does that new shape look like that I just cut? Not the 3-dimensional shape, but the piece where if I have a box, here's my box, ugly box. Sorry, you guys. Let me try that again. I have my box here, rectangular box, long rectangular box. I have my box and I slice it at an angle. So let's say I slice it this way. And then it's what is that shape that's left. So the new shape would be here, making a rectangle. So we're slicing things off. I just want the slice. I don't want the whole three-dimensional shape. It's like if you slice into a watermelon, it's green on the outside and it's pink or red on the inside. What is the shape of the pink? That's what you're being asked. Watermelons are oval or circular, some of them, and then I slice it down the middle. What is the shape of the red? That's what you're being asked. I don't care about the shape of the green on the outside. I want the shape of the red on the inside. So hopefully that helps you guys with cross sections. If you need help with this, I would Google cross section. Well, Google this. It's typed right here for you. Google cross sections of a cone. That might help you answer some of these questions. Draw them in if you need to on here. Please don't forget in 12, parallel means they're never going to touch. So if I have a line here, here's another line. Identify the base of this cone and then deal with parallel. If you're struggling with this, come in and get some help. It could also be something that you ask on Friday when we have our homework question day. All right, the go. The go seems relatively easy. Hey, area of a triangle. Area of a triangle is 1/2 of the base times height. Well, that seems relatively easy. You need to identify the base and you need to identify the height. Please do not forget, your base and your height must be perpendicular to each other. If they are not perpendicular to each other, you do not have a base and the height that goes with that base. So please be very, very careful. I'm not working any of these out for you, but I will help you identify the base and the height just for practice in a couple of these. Always look for a horizontal base. That is the easiest thing to start with. If you have a horizontal piece of a triangle, that is your base. So here's my horizontal piece. From E to G, that is my base. Now your height must be perpendicular to the base. It doesn't need to touch the base, it just needs to be perpendicular. So if I look here, I can easily see my height because they have a perpendicular line drawn in. This is called your altitude. This is my height. Easy to count, both the base and height, but notice how they're perpendicular. You could also find the height anywhere along this triangle as long as it is perpendicular. I could even come over here and find the height of this triangle as long as I have the base and the height being perpendicular. And you just count to the highest point of that triangle. So take your time with this, please. It is not that bad. Plug into the formula. I'm going to skip 17 for just a second, and I'm going to talk to you guys about 18 first. Again, start by identifying the horizontal piece. And you're here in 18, your horizontal piece is EG. That is your base. Now we need to find a horizontal height. Sorry, not horizontal height, a perpendicular height. Well, if I look at EG, if I go up, it doesn't touch the top of the triangle. It doesn't touch the point F, but does it go up to F? Yes. And if I look at this from here and I drag it over to here, those are the same length. They're both perpendicular. Here, your height just happens to be easier to see outside of the triangle. But some of you may be okay starting from anywhere on this triangle, the base of your triangle, and counting up. There's nothing wrong with that. As long as it's perpendicular, and since here's point F, anywhere along that line will give you the height. Anywhere. So here I'm given the height. And again, you're counting and plugging into the formula. Now, 17 is tricky. 17 is tricky because the first thing you should try and find is a horizontal base. There is no horizontal base. But what I am given is the height. I know that's the height because it's perpendicular to what could be the base. So I'm going to make EG my base, and I'm going to make FH my height. Unfortunately, I cannot count either one of those because they are not vertical or horizontal. In order to find the base and the height, you have to make triangles here. Now this point does not line up nicely on this triangle, so just for peace of mind, we're going to move this to the closest vertex that we can find to make this nice. And I'm just going to pretend that that's there. Not a big deal. It's not going to hurt anything. I'm going to draw in a right triangle. And if I draw in a right triangle, I can now find the base. I can use the Pythagorean theorem. I am not going to do this for you. You guys can go through and find the base. You have to do the exact same thing to find the height. I'll let you guys draw in your triangle for the height. You can draw above the line. You can draw below the line. It doesn't matter, but you do need to draw in a right triangle. This right triangle does not count. You cannot find any of those sides. You need to draw a right triangle that has a vertical and a horizontal. Those you can count. So find the height, find the base, and then you guys could plug in and find the area. In 19, you need to calculate the areas of 3 different triangles, and they are drawn on the same grid. So find the horizontal base for each one. You might notice something already. Find the base, and then find the height. Just don't forget, the base and the height must be perpendicular. And you might decide that once you find your base, like, oh, if this is my base, no matter where I'm at, I can just count up. Just make sure it's perpendicular. All right, that's it for 5.1. Any questions you have, make sure you come and see me in the morning or at lunch before we have our homework quiz tomorrow, please. And please make sure you check your answers. See you tomorrow.